Hi grade 8, welcome back to another one of our video lessons. So today we're going to begin with congruency and similarity of different shapes, namely the triangles and the quadrilaterals that we have done. Alright, so I'm going to begin reading on page 123. I want you to follow me. Alright, so we're going to start with congruency. Okay, so let's start with the key words. I'll explain what congruency, similarity, and corresponding means, and as we read through, you'll understand what we are talking about. So, congruent is the same size and shape. So if I say two shapes are congruent, I mean they are exactly the same. So the sides are all the same and the angles are all the same in that shape. So essentially a congruent shape to another shape is exactly that same shape. It can be turned or flipped around or something like that, but if we turn it back or flip it back around, we will get exactly the same shape as before. Now, a shape that is similar is the same shape but different size. Okay, so I could have a square with sides of 2 centimeters each, and then I can have another square with sides of 4 centimeters each. Both of the shapes are squares, so they're both similar to each other, but they are not congruent because one has size of 2, the other one has size of 4, meaning the sides. Okay, so one is twice the size of the other one in terms of distances of each side. Okay, so they have the same shape, but they are either larger or smaller than the other shape. Okay, it's not exactly the same. And corresponding means matching in the same position. Okay, so the sides need to all match up. Okay. All right, so let's begin with congruent. So two or more shapes are congruent to each other if they are exactly the same size and shape. Shapes are congruent if you can flip, turn, or rotate one to fit exactly on top of the other. Congruent figures have equal corresponding sides and equal corresponding angles. Okay, so what I mean by that is that if I have, let's say, a triangle that looks like that, and another triangle that looks like that, well, this angle corresponds to that angle. This angle corresponds to that angle, and that angle corresponds to that angle. Okay. Similarly, we can say that the sides are all the same and they matched up exactly the same. Do you see? So these two triangles are exactly congruent because the corresponding angles are the same and corresponding sides are all the same. Okay. Now, if we look in the blue block, this is what we need for congruency. So congruent triangles have 3 pairs of equal angles and 3 pairs of equal sides. So remember, for congruency, we not only need to make sure the angles are the same, but the sides are the same size, okay? Because remember, I can have a triangle like that, and I can draw a bigger triangle like that, and it will still have the same angles as the inner triangle because it's just parallel lines, okay? But the sides themselves are not the same distance. Therefore, this triangle and that triangle are similar triangles, but they are not congruent triangles. Whereas this inside triangle and that triangle are congruent triangles, okay? So for triangles, we need 3 pairs of equal sides and 3 pairs of equal angles. Congruent quadrilaterals have 4 pairs of equal angles and 4 pairs of equal sides. So guys, congruency is really easy. It's identical shapes. You literally need to match up every side to every other side and every angle to every other angle in the shape that we have, either a triangle or quadrilateral. All right, let's look at similarity. Two or more shapes are similar if they have the same shape but are different sizes. If two or more shapes are similar, their corresponding sides are proportional in the same ratio and their corresponding angles are equal. Okay, I'm going to explain what that means. So let me draw two triangles. So let's say we have a small triangle inside there that looks like this. So I have this angle, and that angle. So different symbols representing different angles. Okay, and the sides here, let's say this is size of 2, 2, and 4. Okay. Now what I'm going to do is I'm going to draw a bigger triangle like that has exactly the same angles as the first triangle. Okay, so the angles are the same, but the sides I've now doubled the side. So this side is going to be 4, that side is going to be 4, and this side is going to be 8. Okay, so what they are saying now is that the ratio between the sides of the two shapes is the same. Okay, so let's try to work out this ratio. Okay, so let's call these triangles A, B, C, and D, E, and F. Okay, so what they're saying is we need to look at the ratio of the lengths of each triangle. Okay, so let's compare AB to DE. Okay, so AB divided by DE is what? Okay, well, AB is 2 over DE is 4, okay, which equals to 1 over 2. So this 1 over 2 is the ratio of the sides of the triangles, okay? So AB is 1 part, DE is 2 parts. So DE is double AB, which is what we have, okay? Well, let's try the same thing for the different sides and see if we get the same ratio. Okay, we've done that. So let's do AC over DF. Okay, remember I'm matching up corresponding sides. So that side and that side, this side and that side, this side and that side. Okay, AC over DE is what? AC is 2, DE is, or DF is 4, and we also get a half. Again, this is saying that AC is 1 part, DF is 2 parts. So DF is twice as big as AC. And we notice that we have exactly the same ratio as before. Right, let's check the other side. So we have CB over FE. Okay, which equals to 4 over 8, which still gives us a half. Okay, again, it's telling us the same ratio, that CB is 1 part, FE is twice that of CB. So CB is 4, FE is 8. Now, once we have, sorry guys, let me just lower that, there you can see. Okay. So what you notice is that all of these ratios of all the sides match up to the same value, which is a half. Now this is telling us that these two triangles that we looked at are similar triangles. Why? Because the ratio of each side to the other side is the same ratio for each side. Okay. So once we get the same ratio, it means the triangles are similar to each other. Okay. Right, so that's how we check similarity. So now if we look at the blue triangle under similarity on page 123, you'll see exactly what I've done. So I've worked out these sides separately and they're all equal to each other because they're all equal to a half. Okay. Similar quadrilaterals have 4 pairs of equal angles and 4 pairs of sides in the same proportion. Okay, so for quadrilaterals, it's going to be literally exactly the same procedure, whereas in a quadrilateral we have 4 sides, in a triangle we have 3 sides. So when you do this for a quad, you're going to have another side that you're going to match up and show me that it equals to the same ratio. Okay. All right, so let's now look at the flowers at the bottom. So it says there are 4 sets of flowers in this picture. Okay. Frame A contains congruent flowers. Okay, so if we look at frame A, there are 4 flowers there, 4 lilies. Okay, you can see that they look all exactly the same. They are the same shape, they are the same size. It's the same image that has been multiplied by 4. So all of those shapes in frame A are all congruent shapes, meaning they are all identical. They are all identical in shape and size. The frame A flowers are similar to the flowers in frame B. Okay, so now we're looking at frame A flower, which is a smaller flower compared to frame B flower. So you can see that frame B, we just enlarged that flower. It's the same flower, just bigger than the previous one. Meaning that there are similar flowers, but they are not exactly the same because one is smaller than the other one. Okay, so it says flowers in frame B because they are the same shape but all different sizes. The flowers in frame C and frame D are distorted. Okay, we can see it's the same image of the flower, but it has been squished or expanded not proportionately. Okay, so guys, the example that I can give you with this is that, remember, let's say you are on your computer and you are in your Word document and you pasted some picture or an image, right? And let's say this is your page, okay, in your Word document, and you've pasted this picture over there, and you'll see that the picture has these little sort of corner bits that you can drag out. So if you hover your mouse over the border of the picture, it will show you those different points, okay? And now if you take your mouse, what you can do is you can take it over here and you can drag it to the right, and you're going to stretch the image out like that, okay? So you're not stretching it out proportionately to the original image. You're only making it wider, but you're not making it higher, okay? If you just pull on one of the dots on left or right here. If you pull on these dots over here, top and bottom in the middle, it's going to distort your image vertically. It's going to pull it outwards going like that. Okay, and again, the image will be distorted. But if you pull your image on the corner dot over here, so here, there, or there, you'll see that the image expands proportionately to your other image that you originally had. So by pulling on the corner dots, you are enlarging or reducing the image proportionately. And that is what similarity is. We're making it larger or smaller, but the proportions of the image are still the same as the original image. So I'm not doing things like frame C and frame D. That would be pulling it on the sides. If I pull it on the corner, I expand it proportionately to both vertical and horizontal. Yeah, I hope that explanation makes a little bit of sense. If you guys don't know what I'm talking about here, go on your computer, open a Word document or create a new Word document by right-clicking, say New Word Document. Go into it and just drag some picture that you have from the internet or wherever. Drag it into the Word document and play around with it by expanding it, making it smaller, and you'll see what I mean with this example over here. All right, cool, guys. So the images C and D are neither similar nor congruent to the original image because they have been distorted. All right, let's continue. When you need to decide whether two shapes are congruent or similar, you need to look at both the angles and the sides. For example, look at these shapes. Okay, so we have three shapes. First, we have a square ABCD. All the sides are 2 centimeters long and we have 90-degree angles everywhere. Okay. If we look at shape 2, guys, I'm looking on page 124. Please open your books and follow me when I'm doing this. Don't just sit and listen to me. Follow me in the textbook, okay? Right, the second shape that I have is a rectangle. It also has all right angles, but the sides are not all the same. And the third image has all the same sides, but no 90-degree angles. Okay, right, so they say ABCD and EFGH are equiangular. Okay, so the square and the rectangle are equiangular, meaning the angles are all the same. But their corresponding sides are neither equal nor in proportion. Okay, meaning that in the first square we had all the sides equals to 2. In the second shape or the rectangle, not all the sides are the same. So they cannot be all in the same proportion to the first picture. Because if we compare sides, we go 2 over 4 is not the same as 2 over 2. Okay, so ABCD and EFG are equiangular, but the corresponding sides are neither equal nor in proportion. So ABCD and EFGH are neither congruent nor similar. ABCD and IJKL, so the square and the rhombus, have equal sides, but their angles are different. So ABCD and IJKL are neither similar nor congruent. So remember, for similarity and congruency, we need to look at both angles and the sides. If all of them match up exactly, the figure is congruent. If the angles match up exactly, but the sides don't, then it could be a similarity. But it doesn't have to be, because we could also have different sizes not in proportion. Okay, like we have the square and the rectangle. All right, guys, let's look at the worked example. Look at these quadrilaterals and then answer the questions that follow. Give reasons for your answers. All right, so we have 4 shapes. They've given us information on these shapes. Let's see what they want. Number 1, identify one quadrilateral that is congruent to PQRS. All right, so let's look at PQRS. That is the green figure in our textbook on page 124. So if we look at that figure, we see that it has all the sides have been given to us. They're 24 millimeters, 24, 11, and 11. And all the angles have also been given to us. So they want us to find another shape that is congruent to this shape. Okay, well, let's look. Let's first match up the sides. So we can see that the bigger picture on the right has sides of 48, 48 and 22, 22. So those are not the right sides. They're not the same. So that can't be it. If we compare the first image and the third image, all the sides match up. Okay, so that could mean that each one of those is a possibility. But now remember, to prove congruency, we also need to match up the angles. Okay, if we look at the first diagram, we can see that the angles do not match up. We have an angle A at 39 degrees. Sorry, guys. Angle A 39 degrees, but angle P is 49 degrees. So the figure 1 and 2 cannot be congruent. Okay, the angles don't match up. If we look at figure 3, we can see that the angles match up exactly and all the sides match up exactly. Okay, meaning that our quadrilateral PQRS is congruent to quadrilateral JKLM. Okay. Now, if you look at the answers, the way you answer this, you can't just tell me this one is congruent to that. You have to explain to me why it is. And remember, the explanation is always you need to match up all the sides. So you literally need to say to me that, well, PQ equals to JK. Then QR equals to KL. RS equals to LM. SP equals to MJ. So you've matched up, you've told me that the 4 sides are equal. Then you need to tell me that all the angles are also equal. So you need to match up the 4 pairs of angles. Once you've matched them up, then you can conclude that yes, the 2 figures are congruent. Number 2, identify one quadrilateral that is similar to PQRS. Okay, so PQRS, we want similarity. So that means the angles need to match up exactly, and the sides need to be in proportion. Okay, in figure 1, ABCD, we can see the angles do not match up to PQRS. Okay, so that can't be it. We also know that the third image, JKLM, is congruent to the second image. So they can't be similar because they're exactly the same. Okay, so that leaves us with the last image to consider. Well, let's look at the last image. Do the angles all match up? The answer is yes. We have 49, 49, 131, 131, and the other 2 angles are 90 and 90. Right, so that is good. We are on our way to proving similarity. But remember, we also need to show that the sides are in proportion. So you need to show me the ratios like this on the board for the matching sides. So you're going to say that while PQ over TU equals 24 over 48, which is a half. Then you're going to match up the other 2 sides and show me that it's also a half, and so on for the other 2 sides. Once you've done that, you can conclude that the 2 shapes are similar. So guys, if I was speaking too fast, you can follow the answers in the worked example, and they're literally literally do what I'm saying. Okay, I just don't want to rewrite all the stuff because you have it in front of you right there. Okay, guys, so right, number 3, which quadrilateral is neither similar nor congruent to PQRS? Explain your answer. Okay, well, we already answered that question in the analysis because we said figure 1 is neither congruent nor similar. Because remember, for congruency, you need to match up all the angles. For similarity, you need to match up all the angles. If the angles do not match up, then it's neither congruent nor similar. And that's what's happening in our first and second image. Okay. And then question 4, classify quadrilateral PQRS. Okay, well, that one is easy because we can see that we have adjacent sides equal. Okay, so 2 pairs of adjacent sides equal, it means that we are dealing with a kite. All right, guys, so what I want you to do for this lesson is do exercise 11.6, that's classifying quadrilaterals and triangles and proving congruency and similarity. In the next lesson, I'm going to continue with the next page, 126. I'll solve problems that involve triangles and quadrilaterals, and you guys are going to do exercise 11.7. And then we are done with this section, which is great, which means that we'll move on to, I'll tell you now, our next section is going to be geometry of straight lines, okay, which is pretty basic. All right, cool, guys. I hope you enjoyed the lesson, and I'll see you next time. Thank you.